Good morning, ladies and gentlemen. Today you're going to be talking about Bohr models and electron dot diagrams. So we have a modern model of the atom. In the modern atomic model, electrons can be found only in certain energy levels, not between the levels. Therefore, the locations of electrons cannot be predicted precisely. Bohr suggests that the energy of each electron was related to the electron's path around the nucleus. Electrons only have a certain amount of energy. Electrons must either gain energy to move to a higher level or lose energy to move to a lower level. The new atomic model describes electrons as they behave more like waves on a vibrating string than like particles that have a fixed position. Determining the exact location of electron in an atom and the speed and direction of the electron is impossible. We just refer to the space they are as electron orbitals or just orbitals. Electrons orbit the nucleus in fixed orbits called energy levels. Electrons have various amounts of energy existing in different energy levels. The number of energy levels that are filled in an atom depends on the number of electrons. Electrons on the very outer energy levels of an atom are called valence electrons. So the ones on the outermost level are called valence electrons. In our model, we have different energy levels, and each energy level holds a different number of electrons. The first energy level holds 2 electrons, the second holds 8, the third holds 18, and the fourth holds 32. We begin filling the electrons from the lowest energy level up to the highest energy level. Electrons can jump between energy levels when an atom gains or loses energy. The lowest state of energy is called the ground state. Electrons that gain energy move to an excited state. Electrons that fall to a lower level release a photon. A photon is a particle of light. A specific amount of energy is released to give a certain wavelength of light. The wavelengths are different for each element. It is called an atomic fingerprint. Here are some examples of Bohr models and how to draw them. So first, I notice that I have sodium 23. And if you look at a periodic table, that means sodium is Na. It has 11 protons, 12 neutrons. Remember, I get neutrons by subtracting my mass minus my protons. So 23 minus 11 is 12. And these are all neutral, so it has the same amount of electrons. So in this first circle, in the very center, I'm going to write P equals 11, N equals 12. And then I'm going to start drawing my electrons. So I'm just going to use dots. 1, 2 on my first level. I have 11 to place. On my next level, I can do up to 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 placed. I need to place one more. And I'm done. So in my first circle, I have 2 electrons. In my second circle, I have up to 8 electrons. In my third circle, I have up to 18 electrons, but I only have 1 to place. There are 11 total electrons here for sodium. If I asked you the number of valence electrons, which are on the outside. There is 1 electron on the outside. Next, we have fluorine. When I look at fluorine, I notice that its atomic number is 9, so it has 9 protons. To find neutrons, I take my mass number minus my number of protons, so 19 minus 9, 10 neutrons. And my number of electrons is the same as my protons, so that's 9. Very center, I'm going to write my protons and neutrons. Now I'm going to place my 9 electrons. Our first circle, first orbital can get 2. Our next circle can get 8, but I only have 9 to place total, and I've already placed 2. So my second shell is going to get 7. Count it up, I have a total of 9 blue dots, so for 9 electrons. So I'm done. If I ask you the number of valence electrons on this, there are going to be 7 valence electrons on that last shell. In our next little part, I'm going to show you how to draw a Lewis structure or an electron dot diagram. Same thing. It is an abbreviated Bohr model that only shows the valence electron. Let's try to do one together. We'll start with the Bohr model of lithium. So I have lithium 7. When I look on the periodic table, lithium has an atomic number of 3, so that means it has 3 protons. To find neutrons, I take my mass minus my atomic number, so it has 4 neutrons, and my electrons are the same as my protons because this is a neutral atom. In my center, I'm going to write P equals 3, N equals 4, and I'm going to begin to place my 3 electrons. On my first, I have 1, 2, and then 1 more to place. I have a total of 3 electrons. The number of valence electrons. How many are on the outermost shell? 1. When I place my valence electrons, there is a certain way to do it for the electron dot diagram. That's what this is telling us. So our first step to write our Lewis structure or electron dot diagram is to write the symbol for the element. And we're going to put it in the center of this box. Li. Okay, and then we have 1 electron to place. Let's change the color here so you guys can tell the difference. And I'm going to start right here. That's going to be my 1 electron. And that's it for lithium. This is exactly what your homework looks like. So we're going to go ahead and do oxygen together. You should be able to type in all of these white boxes whenever you get it. So for oxygen, I have an atomic mass of 18. If I look up the atomic number for oxygen, it should be 8. The symbol for oxygen is O. My atomic mass is 18. How many protons does it have? Same as the atomic number, so 8. How many neutrons does it have? To find neutrons, again, I take my mass minus my number. So 18 minus 8, so it has 10 neutrons. Then I'm going to place these electrons. So you can drag and drop these electrons when you actually have this going. You can drag and drop these electrons to wherever you need them to be. Okay, so I just have to draw them in because of the program that I'm in. So I have 2 on my first row. I'm placing 8 because that's the same as the number of protons, 2. Then I have 6 more to place. 1, 2, 3, 4, 5, 6. Okay. Again, you would just be dragging these negative reds over to the thing, over to the model. The last step here is the Lewis dot diagram. So I'm going to write an O in the white circle. How many valence electrons does it have? How many are on the outside circle? So it has 6 valence electrons. I need to place them 1 on each of the 4 sides. And then pair it up until I run out of electrons. All right, if you guys have any questions, please let me know. There is homework where you're essentially doing a page just like this. So you'll drag and drop the electrons where they belong. You'll write protons and neutrons in there, figure out the atomic number, symbol, and mass, and you'll draw the Lewis dot structure here. You guys have any questions or comments, let me know if I can help you in any way. Have a great day.